shall return.
53 years ago, humans walked on the moon. Since then, we haven't gone back. However, things are about to change. These 4 astronauts will fly around the moon facing radiation levels and isolation that no one has experienced in half a century. And what happens on this 10-day journey determines if humans can survive the trip to Mars. This mission decides if we're ready to become an interplanetary species and send humans to another planet for the first time in history. So why has it been over 50 years since humans left Earth's orbit? December 1972 was the last time humans traveled to the moon. After that mission, NASA's Apollo program ended, which meant no more moon missions and no more deep space travel for humans. For 53 years, astronauts have stayed close to Earth in low Earth orbit on places like the International Space Station, which sits just 250 miles above the planet. That's close enough that Earth's magnetic field still protects astronauts from most of the dangerous radiation in space. However, going to the moon means leaving that protection and venturing into deep space where radiation levels are much higher and the risks are much greater. For over half a century, humans have been trapped in low Earth orbit, and Artemis 2 is about to break that barrier. But you know what? The real question is why go back to the moon now after all this time? It's February 6, 2026, and the launch window opens at Kennedy Space Center in Florida at Launch Complex 39B. The Space Launch System rocket stands 322 feet tall, which makes it the most powerful rocket NASA has ever built. And sitting on top of it is the Orion spacecraft, where 4 astronauts will spend the next 10 days. This mission, called Artemis 2, builds on the success of Artemis 1, which was an uncrewed test flight in 2022 that sent an empty Orion spacecraft around the moon and back to verify the systems worked. However, Artemis 2 is different because this time there are people on board, and their job is to test everything humans will need to survive in deep space. This is NASA's first crewed deep space mission in over 50 years, and it's happening in just weeks. So, get this. What exactly will the astronauts do during this 10-day mission? After launch, the Orion spacecraft will spend about a day in high Earth orbit testing all of its systems, including life support, navigation, and communications, while the crew performs checkouts and makes sure everything works properly. Then comes the big moment, when Orion fires its engines for the translunar injection burn, which will send the spacecraft on a trajectory toward the moon, traveling at thousands of miles per hour. The journey to the moon takes about 4 days, and during that time, the astronauts will be monitoring systems, gathering data, and performing course corrections as needed. Now here's where it gets intense. Orion will fly around the far side of the moon at a closest approach of about 4,000 miles from the lunar surface. And this is the part that makes Artemis 2 truly historic. The astronauts will see parts of the moon that human eyes have never seen before, because they'll be looking at the far side while it's illuminated by the sun, which creates views that no Apollo crew ever experienced. During the 45 minutes when they're closest to the lunar surface, the crew will be completely cut off from Earth, with no communications because the moon itself will block all signals. The astronauts will travel further from Earth than any humans in history, and they'll be completely alone for 45 minutes with no way to call for help. But here's what makes this mission truly dangerous. When astronauts are on the International Space Station, they're still within Earth's protective magnetic field, which shields them from most of the harmful radiation that comes from the sun and deep space. However, Artemis 2 will take the crew well beyond that protection into an environment where radiation levels are significantly higher. The spacecraft will be carrying multiple radiation sensors and dosimeters to measure exactly how much radiation the astronauts are exposed to during the mission. The crew will also be providing saliva and blood samples before, during, and after the flight so scientists can study how their immune systems respond to deep space radiation. Here's something fascinating. One of the experiments, called Avatar, uses organ-on-a-chip technology where tiny chips containing cells from the astronauts' own bodies will be carried on the mission to see how individual organs respond to radiation and microgravity. This data is critical because if humans are going to travel to Mars, which takes 6 to 9 months each way, NASA needs to know if astronauts can survive that much radiation exposure. The crew will also be testing their ability to sleep, work as a team, and perform tasks in the confined space of Orion, which has about the same interior volume as a studio apartment. The astronauts will face radiation levels never experienced by humans before, and their bodies will provide the data NASA needs for Mars missions. So why does this mission matter for getting to Mars? Mars has been NASA's ultimate goal for decades. But there's a fundamental problem with getting humans there, and that problem is distance. The Moon is about 240,000 miles from Earth, which means a round trip takes about 10 days. However, Mars is about 140 million miles away at its closest approach to Earth, and a round-trip mission would take around 2 to 3 years. That means astronauts would spend months in deep space exposed to radiation, living in cramped quarters, dealing with isolation, and relying completely on their spacecraft systems to keep them alive. Before NASA can send anyone to Mars, they need to prove that humans can survive those conditions, and that's exactly what Artemis 2 is testing on a smaller scale. But you know what's interesting? The mission is gathering data on how radiation affects the human body, how well life support systems work in deep space, how crews perform under stress and isolation, and whether the Orion spacecraft and its systems can be trusted for longer missions. The crew will survive the fastest re-entry in human history, and if everything works, Mars becomes possible. So, what does this mean for the future of human spaceflight? Artemis 2 is more than just a test flight around the Moon. It's the gateway to humanity's future in space. For 53 years, humans have been confined to low Earth orbit, unable to venture beyond Earth's protective bubble. But this mission changes everything. If Artemis 2 succeeds, it proves that NASA's deep space systems work, that humans can survive beyond Earth's magnetic field, and that the path to Mars is real. The 4 astronauts on this mission are pioneers, testing technology and gathering data that will be used for decades of future exploration. Artemis 3 will land humans on the Moon's south pole in 2027 or 2028. Artemis 4 will deliver the first module of the Lunar Gateway in 2028, and subsequent missions will establish a permanent human presence on and around the Moon. All of this leads to the ultimate goal, which is sending humans to Mars sometime in the 2030s. The technologies being tested on Artemis 2, including advanced life support systems, radiation shielding, deep space navigation, and long-duration spacecraft operations, are the same technologies that will be needed for a Mars mission. The data being collected on how the human body responds to deep space radiation, isolation, and confinement will directly inform how NASA protects crews on the multi-year journey to Mars. Artemis isn't just about going back to the Moon. It's about learning how to live and work in deep space so that humans can explore further than ever before. February 6th, 2026 could be the day that opens the door to Mars, to the outer solar system, and to a future where humans are no longer confined to one planet. Humans haven't traveled beyond Earth's orbit since December 1972, which is over 50 years of staying close to home in low Earth orbit. Artemis 2 is about to end that drought with a 10-day mission that will send 4 astronauts around the Moon and test every system needed for deep space exploration. This is why people are watching, because after half a century of waiting, humans are finally going back to deep space. And this mission will determine if we're ready for Mars.